I want you to imagine, just for a second, that you have just made the absolute hire of a lifetime.
Okay, I'm picturing it.
Right. So you've managed to recruit the most brilliant, lightning-fast worker on the planet. I mean, this person is a total prodigy.
The dream employee, basically.
Exactly. You sit them down at a desk, you give them a seemingly impossible task,
Yeah.
and you just watch them work. And it is honestly breathtaking to see.
I bet.
Like, if your company's entire cloud infrastructure goes down,
Yeah.
throwing hundreds of error codes everywhere, this worker can just instantly ingest all of it.
Just read the whole matrix right there.
Yeah, diagnose a massive system failure and write, thousands of lines of perfect remediation code before you've even had a sip of coffee.
Which is wild.
It is. They are the perfect employee by every metric. But there's a catch.
There is always a catch.
And it's a massive, completely debilitating catch. Every single time this brilliant worker blinks, their entire memory is wiped completely clean.
Oh, wow. Just gone.
Absolutely spotless. They forget who they are, they forget what they just did, and they entirely forget where they put the brilliant code they just wrote.
That sounds incredibly frustrating.
One blink, and it's all gone. Back to a blank slate, just staring blankly at the screen.
It's a phenomenal thought experiment because it captures the exact frustration happening in enterprise tech right now.
Right, with AI.
Exactly. You have all of that raw intellectual capability, unfathomable processing speed, but absolutely zero continuity.
Because it just resets.
Yeah. Every single interaction is functionally the very first interaction. There's no building of knowledge over time.
There's no ongoing context at all.
Right. And when you're trying to get meaningful, long-term work done within a business, raw intelligence without persistent memory is, well, it's practically useless.
Because you spend all your time just bringing the genius up to speed.
Exactly. Only for them to forget it the literal moment the task is over.
So that incredibly frustrating scenario, it's not science fiction. That is exactly what is happening right now at the cutting edge of enterprise tech.
Yep, it really is.
So today, we are going on a mission. We are taking a deep dive into the fascinating mechanics of something called agentic storage.
And this groundbreaking new standard, the Model Context Protocol, or MCP.
Right, MCP. We're pulling our insights today directly from some fantastic research put together by the folks over at IBM Technology.
We've done some really great documentation on this.
They really have. So our goal for this deep dive is to understand exactly how the tech world is scrambling to cure AI of this inherent amnesia.
It's a massive undertaking.
Okay, let's unpack this. Because to really grasp why this is such a huge deal, we have to talk about this shift happening in the AI space right now.
Yeah, for the past couple of years, the public's imagination has just been captured by chatbots.
Right, ChatGPT, Claude, all of those.
Exactly, and most corporate investment went there too. You type a prompt, it types a brilliant answer back.
It's a conversational interface. We talk, it talks.
Right. But we are rapidly hitting the ceiling of what a chatbot can actually accomplish for a business.
Because at the end of the day, it's just talking.
Exactly. We're moving away from systems that just talk to us and entering the era of agentic AI systems.
Agentic AI, so these are the doers.
Yes. Autonomous systems that don't just generate text for you to read, they go out into a digital environment and actually execute work on your behalf.
So they're writing the software, deploying the code, managing network traffic.
Remediating critical IT incidents autonomously, yeah. We are transitioning from talkers to doers.
Talkers to doers. And that transition, it completely changes the stakes.
It absolutely does.
Because if an AI is just talking to you, the chat log itself is the final product.
You read it, you copy it, you're done.
Right. But if an autonomous agent is doing actual work writing Python scripts, moving financial files around, it fundamentally needs a place to put that work.
It needs a desk.
Yeah, it needs a desk, it needs a filing cabinet, an environment where its labor actually lives.
And right now, out of the box, an AI essentially has nothing.
Which naturally brings us to the core issue holding all of this back, the goldfish memory of artificial intelligence.
Right. To understand why agentic storage even needs to exist, we have to look under the hood at the fundamental flaw of large language models.
The LLMs, the brains of these systems.
Yeah. At their architectural core, LLMs are what computer scientists call stateless entities.
Stateless. I hear that word thrown around a lot in software engineering, but what does it actually mean for AI to be stateless?
It basically means the model itself is frozen in time.
Frozen how?
The underlying neural network, it doesn't hold on to anything from one moment to the next. It doesn't learn or remember anything from your specific conversation.
Oh, right. So when I close the tab, it's gone.
Exactly. When you spin up an AI agent, its entire working memory exists only inside something called the context window.
The context window. And the IBM source had a really brilliant comparison for this, right?
Yeah, they compare the context window to RAM in a standard computer. Random access memory.
Okay, so for those of us who aren't, building gaming PCs on the weekends, RAM is that super fast short-term memory.
Right, it's what your computer uses.
50 browser tabs open at once.
Exactly. But the defining feature of RAM is that it is incredibly volatile.
Volatile meaning temporary.
Highly temporary. When you pull the plug on your computer or even just restart it, everything in the RAM is instantly wiped out.
It does not persist.
No, the hard drive is where things persist. The RAM is just your immediate workspace.
And the context window of an AI operates on that exact same principle.
Exactly the same. It holds a certain amount of text or code in its active thought process, but the moment the session ends,
Or the moment the window gets too full.
right, when it hits its token limit, the memory effectively resets. The RAM is flushed.
It entirely forgets what it just did, the problem it was solving, everything.
All that brilliant work just gone.
I want to try an analogy here to really lock this visual in for you guys. Let's say our AI agent is a world-class Michelin star executive chef.
I love food analogies. Go for it.
So in this scenario, the context window is their cutting board.
Okay, their immediate physical workspace.
Right. It's absolutely fantastic for chopping vegetables right now in this exact second.
They can see the onions, the carrots, the knife.
They're working at incredible speed.
Yeah.
But the structural problem is, once the meal is plated and sent out to the dining room.
Meaning the session ends.
Exactly.
Okay.
Or once that cutting board simply gets too piled up with ingredients, the entire cutting board is just picked up and dumped directly into the trash.
Just wiped completely clean.
Yep, by an invisible hand. The chef has no memory of ever cooking the meal, all the leftover ingredients are gone, and if you ask them to make a second course, they start from absolute scratch.
And if you apply that chef analogy to a massive enterprise IT environment, you immediately see why this is a nightmare.
It's totally unworkable.
Right, because if you deploy an autonomous agent, your goal isn't to have it answer trivia.
You want it managing complex projects.
Yes, monitoring system health over a period of weeks, noticing subtle trends, and then independently writing and testing custom security patches.
But it can't monitor anything over a period of weeks if it dumps the cutting board into the trash every time it blinks.
Exactly. That inherent amnesia is the biggest bottleneck in AI today.
It's a massive roadblock to true utility.
Imagine an agent spends an hour analyzing a convoluted server error log. It develops a brilliant strategy to fix it.
But the sheer size of the logs fills up the context window.
Right, causing to flush, or the session just times out. All of that cognitive labor, all that brilliant deduction just vanishes into the ether.
It's as if the work never happened.
Completely gone.
But, engineers are incredibly stubborn problem solvers.
That they are.
They aren't going to just sit back and accept that their multi-billion-dollar models have zero memory. They had to come up with a fix.
Or at least a highly elaborate Band-Aid.
Right. Which leads us to the tech world's first major attempt to give AI a memory bank, RG.
Retrieval Augmented Generation, RDAY.
If you've paid any attention to AI over the last year, RG has been the inescapable buzzword.
Oh, it's everywhere. And the fundamental idea was to address this lack of state by giving the AI a fast, organized library to pull from before it speaks.
So break down the mechanics of that. How does RJ actually operate under the hood?
So RG essentially connects your stateless LLM to a specialized piece of infrastructure called a vector database.
A vector database. Think of that like a mathematically organized filing cabinet, right?
Exactly. An enterprise takes all its persistent knowledge employee handbooks, HR policies, historical data, code, and loads it in.
But it doesn't just store them like regular text files on a hard drive. I know vector databases do something weird with the data.
Yeah, they translate human language into mathematics.
Mathematics, like numbers.
Basically, when you load a document, it chops the text up and assigns it coordinates in a multidimensional space.
All the embeddings.
Yes, creating embeddings. So concepts that are similar in meaning end up physically clustered closer together in this mathematical space.
So like the word dog and the word puppy are near each other.
Exactly. Or server crash and latency spike.
Got it. So the AI has access to this massive mapped library.
Right. When you assign the agent a task, it doesn't just rely on its immediate RAM. First, it queries that vector database.
It does a semantic search.
Yeah, looking for underlying meaning, not just exact keywords. The database finds the relevant documents and pulls them right into the AI's context window.
Before it even begins to generate a response.
Exactly.
So going back to our amnesiac chef, before they start cooking, they realize their cutting board is empty.
So they run to the recipe library.
Right. They find the recipe for beef bourguignon, memorize it for that immediate moment, bring those specific ingredients to the cutting board, and start cooking.
That perfectly illustrates the workflow. And, on paper, it sounds like a triumph, doesn't it?
It does. It sounds like we cured the amnesia by giving the model access to infinite memory.
It's a phenomenal illusion of memory.
Wait, an illusion. Because if AVA allows the AI to instantly read the employee handbook and pull up the server history before it acts, hasn't it functionally solved the problem?
Well, for a chatbot whose only job is to answer questions, RAG is a perfect solution.
But for an agent.
For agentic work, RAG fundamentally fails. Because RAG is, strictly speaking, a read-only architecture.
Read-only. Let's really explore the limitations of that.
It comes down to the flow of data. RAG successfully solves the input problem.
Getting info into the model.
Right. It's great at getting vital information into the context window so the AI can make an informed decision, but it completely ignores the output problem.
The output problem being the actual work the agent creates.
Exactly. Sure, the AI can read the company policies, it can read the error logs, but what happens when it writes a brand new, highly complex Python script to fix the server?
Or creates a customized remediation playbook. Where does that actual work product go?
Because it's still operating with that volatile RAM, it just vanishes when the window fills up.
It just vanishes.
Arad gives the AI a library card so it can check books out and read them, but it absolutely does not give the AI a pen or a notebook.
It doesn't give it the authority to write its own thoughts down.
Exactly. It can't save them on the shelf. Arad cannot write back to the storage systems.
So the agent does the brilliant work, the session ends, the window flushes, and the script is gone forever.
Yeah, gone.
That is maddening.
It really is.
It's literally like having the world's greatest scholar locked inside a massive library. They can read every book ever written, they can formulate the most profound theories, but they are completely paralyzed.
They cannot write a book of their own and leave it for the next generation.
They can't contribute to the institutional knowledge. They're just a transient processor of information, not a builder of lasting value.
Which is exactly why the tech industry had this collective realization: solving the input problem was only half the battle.
We have to solve the output problem.
We have to give the AI a place to permanently safely store its work product. And that realization forces us past RAG and brings us to agentic storage.
We need to give the AI its own hard drive.
Yes, essentially.
But wait, if the goal is just giving the AI a hard drive, why is agentic storage a whole new, massive category of enterprise tech?
It sounds so simple, right?
Yeah. Why can't a software engineer just plug a standard USB hard drive into the server and, map a D drive for the AI?
It is incredibly tempting to view it through a human lens,
Right.
to assume we just point the AI at a hard drive and hit save.
We do it 10 times a day when we hit save as.
Right. But a standard hard drive architecture is entirely insufficient and honestly unworkable for an autonomous intelligence.
Why is it unworkable?
Because agentic storage is vastly more complex. It has to be a storage layer that is explicitly aware of and designed exclusively for non-human actors.
What's the actual barrier to using regular storage? Why can't the AI just hit save?
It comes down to a structural bottleneck that the IBM source perfectly describes as the integration nightmare.
The integration nightmare.
Think about how you, as a human, interact with a file system. You have a monitor, you have a mouse.
Right. I click the File menu, click Save As.
A graphical window pops up, you click a folder, you hit save.
Super easy.
But an AI agent doesn't have a mouse. It doesn't have eyes to see a graphical user interface.
Right.
To give an AI the ability to interact with a file system, developers have to write custom code. Specifically, custom API integrations.
Okay, let's define API really quickly for clarity. An application programming interface.
Exactly.
Basically a menu, right? A stripped set of rules that dictates how one piece of software asks another to do something.
Perfect definition.
So a developer writes code that translates the AI's intent into the specific API commands of the hard drive.
Right, they teach the agent exactly how to speak the programmatic language of that specific storage system.
But developers do that kind of integration all the time. That doesn't sound like a nightmare.
They do it for single applications, sure. But now multiply that by the sprawling, chaotic reality of modern enterprise IT infrastructure.
Ah, right. It's never just one hard drive.
Never. In a Fortune 500 company, data doesn't live in one neatly organized place. An enterprise might have one massive storage system dedicated purely to object storage.
I know object storage is huge in cloud computing. What makes it distinct?
Object storage is essentially a massive, flat bucket. There are no folders, no directories.
Oh, really?
Yeah, it's designed to hold phenomenal amounts of unstructured data, millions of photos, raw video files, immense data lakes.
Like Amazon S3.
Exactly like Amazon S3. You retrieve things based on unique ID tags, not folder paths.
Okay, so that's one system.
Right, but then right next to that, the exact same company might have a completely separate system running block storage.
And block storage is different.
Entirely different architecture. It takes data, chops it up into equally sized blocks, and stores them wherever is most efficient.
So it's not a bucket.
No, it's lightning fast, highly structured, and typically used to run heavy enterprise databases where you need immediate read-write speeds.
Okay, so that's two completely different systems.
And then over in the accounting or HR department, they might have a third system running NAS network-attached storage.
That's the one most people are familiar with, right?
Yeah.
The shared drive on the Office network, where you click through a tree of folders to find the Q3 spreadsheet.
Exactly. It operates on a hierarchical file system. So you have object storage, block storage, and NAS.
Three totally different worlds.
These are not just different brand names, they're fundamentally different data architectures.
Right.
They each have entirely different API menus. They use completely different logic models to organize information.
Which means the code to talk to them is totally different?
Vastly different, and perhaps most frustratingly for a developer, they have wildly different authentication mechanisms.
Oh, security.
Yeah. The way a piece of software proves its identity to write a file to an Amazon S3 object bucket looks absolutely nothing like the security handshake for a local NAS drive.
Okay, so let's look at what that actually demands of a human developer.
It's a lot.
If you want your AI agent to be truly useful across your company, if you wanted to pull an image from object storage, analyze it, update a record in the block storage database, and then save a summary to the NAS drive?
You have to manually teach the AI to speak 3 entirely different proprietary languages.
That is wild.
And the nightmare doesn't end when you finish writing the code. You have to constantly maintain it.
Because software updates.
Exactly. Every single time the NAS vendor updates their software or Amazon changes a protocol, your custom API integration breaks.
And suddenly your autonomous agent throws a silent error and fails to save its work.
The entire automated workflow collapses. Maintaining bespoke integrations for every storage system simply does not scale.
It's a total logistical impossibility. I'm just picturing this thoroughly burnt-out engineering team trying to teach an AI a dozen different languages just so it can save a text file.
It's an awful job.
It's like hiring that amnesiac prodigy from the intro and telling them, oh, by the way, the filing cabinet speaks Russian, the desk drawer understands Mandarin, and the trash can requires a password in ancient Latin.
Good luck storing your work.
Right. If an AI can't seamlessly access the infrastructure becomes useless.
You cannot build an autonomous digital workforce if that workforce can't open the digital filing cabinets.
So the industry hit a wall.
A massive wall. They realized they desperately needed a universal translator.
A single standardized interface.
Yes. Something that would allow an AI agent to talk to literally any storage system on the planet. Object, block, NAS, cloud, without the human developer writing a single line of custom integration code.
And that desperate need is exactly what birthed the Model Context Protocol, or MCP.
The universal translator.
It is rare and beautiful when the tech industry actually agrees on a standard instead of building walled gardens.
It really is a game changer.
So if we look at the architecture of MCP, how does this universal translator actually function?
The architecture is surprisingly elegant. The IBM source breaks MCP down into 3 core components.
Okay, what's the first one?
First, you have what's called the MCP host.
The host.
Yeah.
Just to be clear, that's the actual application environment where the AI agent is running, right?
Correct. It's the software program that houses the LLM brain itself, the agent's immediate environment.
Okay, so the AI lives in the host. What's next?
Below that, on the other side of the equation, you have the MCP server.
The server.
Right. In our context of agentic storage, the MCP server acts as the intelligent layer sitting on top of the actual storage hardware.
So it's the middleman.
Exactly. And here is the magic of the architecture. The MCP server completely abstracts the underlying hardware.
Abstracts it. meaning it hides it.
Yes. The AI agent sitting in the host doesn't need to know, and in fact has no idea, if it's talking to an S3 bucket, a block database, or a dusty NAS drive.
Doesn't care at all.
Nope. The MCP server wraps all that proprietary complexity up and presents one single uniform menu to the agent.
The agent just sees a generic box labeled Save Data Here, and the server figures out which filing cabinet it goes into.
Exactly. It turns the key.
I love that. So you have the host, you have the server. What's the third piece?
Connecting them is the protocol itself. It dictates how they communicate using something called JSON RPC.
JSON RPC. I mean, that sounds like a heavy dose of alphabet soup.
It does, but it's much simpler than it sounds.
What's it actually doing under the hood?
JSON stands for JavaScript Object Notation. It's basically a clean, standard text format for exchanging data that machines can easily parse.
Okay, and RPC.
Remote procedure call. So JSON RPC is essentially a highly structured text message.
Just a text message.
It's a standardized way for the agent to send a message to the server saying, hey, execute this specific procedure for me, and here are the parameters.
So the agent formats a text message, sends it across the protocol, and the server executes it.
Right.
But the real power of MCP isn't just the messaging system itself, right? It's what the server actually allows the agent to do.
That's the crucial distinction. The MCP server exposes specific capabilities to the agent through what it calls primitives.
Primitives.
Think of primitives as the fundamental building blocks of interaction. The source highlights two incredibly important ones: resources and tools.
Let's break those down, because they really seem to represent the two halves of the memory equation. What is a resource?
A resource is a passive data object.
Passive meaning you just read it.
Exactly. It's persistent information that already exists somewhere in the infrastructure. A legal document, a config file, database records.
So when the agent is executing a task and suddenly needs more context,
say it's writing a firewall rule but needs the current security policy.
it sends a JSON RPC message requesting that specific resource.
Yes.
Wait, conceptually, requesting a resource through MCP sounds incredibly similar to what we were just talking about with RAG.
It is. The conceptual goal is identical. Get context into the model. But the execution is revolutionary.
How so?
Because instead of a company building a massive custom vector database pipeline just to feed the model, MCP provides a universal interface.
Any storage system running an MCP server can instantly serve up resources to any agent.
Exactly. It's an infinitely cleaner, universally adopted way to solve the input problem.
Okay, so the resource primitive solves the input problem. It lets the AI read existing data effortlessly.
Right.
But we spent 20 minutes establishing that reading is not enough. The AI needs a pen. It needs to write.
And that is exactly the function of the second primitive, the tools.
Tools.
While resources are passive data you read, tools are active, executable functions.
The server exposes functions the agent can actively invoke to change its environment.
Yes. The source text lays out 4 critical examples of tools. First, the agent can invoke list directory.
So it can look around and see what files exist in a folder.
Exactly. Second, it can invoke read file, pulling the actual contents.
Situational awareness.
Yes. But the third tool is the paradigm shift. Write file.
Write file.
The agent can finally take that brilliant Python script it generated in its context window, format a message, and permanently write that script to the physical disk.
It creates persistent state.
It does. And fourth, it even has tools like Create Snapshot, allowing the agent to autonomously back up the server before making changes.
Just in case something goes wrong.
Exactly.
Think about the sheer scale of what this unlocks. Our brilliant agent is sitting in the host. It diagnoses a crash, writes a playbook.
It doesn't care if the data is on Amazon or a local drive.
It simply formats a standard text message. Invoke tool, write file. Here is the playbook.
The MCP server catches that message, translates it into the proprietary API language, authenticates, and saves the file.
The AI finally has a universal hard drive. We've cured the amnesia.
We have. Functionally, it is an absolute engineering triumph. The agent can persist its work, learn over time, and build institutional knowledge.
The output problem is solved.
Solved, but
There's always a but when things sound too perfect.
there is a massive existential but. Because the moment you take a step back and realize what we've just done,
What have we done?
we have just given an autonomous, non-human intelligence the universal capability to easily write data, execute tools, and manipulate files across our entire enterprise storage infrastructure.
Oh, I see.
Yeah, a massive, glaring red flag should be going up in your mind right now.
Because if a machine has the power to write a file, it inherently has the power to overwrite a file.
Exactly.
If it has the tools to create massive amounts of data, it has the tools to delete massive amounts of data.
And this brings us to the perspective of what the IBM source playfully refers to as the skeptical security-focused buddy.
The security buddy. In the real world, this is the CISO, right? The Chief Information Security Officer.
Yes. And if you casually stroll into a CISO's office and enthusiastically explain that you've installed a universal translator giving an AI agent unfettered right access to the core storage,
They are going to have an immediate panic attack.
a total meltdown.
Because at that point, aren't we just handing the keys to the kingdom over to a machine?
We are.
I mean, I trust my computer to run spell check, but am I seriously supposed to trust it to rewrite the SQL database holding our global payroll?
But that deep skepticism is not just healthy, it is mandatory for survival in modern IT.
Why is it uniquely dangerous with AI?
Because we have to remember the fundamental psychological nature of LLMs. They possess staggering processing power, but they are not flawless calculators.
Right, they hallucinate.
They frequently hallucinate.
Hallucinations being when the AI just confidently invents a totally fabricated fact or makes a massive logical leap.
Simply because its statistical model predicted the output sounded mathematically plausible.
It lies with absolute confidence.
Precisely. And beyond outright hallucinations, AI agents can incredibly easily misinterpret human instructions.
Human language is inherently messy.
Very ambiguous. If a human manager gives a vague instruction, the employee uses worldly context to ask for clarification.
But an AI agent doesn't possess worldly context.
No. It might just aggressively execute the most mathematically probable interpretation of that vague instruction at the speed of light.
And when you equip that agent with a delete file tool via MCP,
a hallucination is no longer just a funny wrong answer in ChatGPT.
right, it's a highly destructive action on your actual corporate hard drive.
The source task uses a profoundly powerful phrase for this exact threat. It warns that an AI might take actions that seem logical in isolation, but are catastrophic in context.
Logical in isolation, catastrophic in context. That's a terrifying combination of words.
It really is.
Let's explore that. What does that actually look like in a real enterprise environment?
Let's construct a very plausible scenario. Imagine you deploy a highly capable IT management agent via MCP. You give it a standard instruction. Please optimize our server storage. Scan the drives and free up space wherever possible so we can save on cloud hosting costs.
That sounds like the exact tedious, busy work we want AI to do. Go find the digital junk and throw it away.
Right, so the agent goes to work. It uses its list directory tool to scan petabytes of storage.
Okay.
Deep in the architecture, it finds a massive folder containing the company's entire historical financial database for the last decade.
Oh no. I see exactly where this runaway train is heading.
The agent analyzes the metadata and realizes that no human has accessed these specific files in the last 7 days.
Oh boy.
To the AI's internal logic, this is a perfect match for your instruction. The files are enormous, they take up expensive space, and they haven't been touched recently.
Therefore, deleting them perfectly optimizes the storage.
It hits the metric. It is entirely, undeniably logical in isolation.
But it is completely catastrophic in context.
Yes.
Because that financial database is legally required for IRS tax compliance. Deleting it might literally destroy the company.
But the AI doesn't understand the abstract human meaning of the tax code. It only understands file sizes, access dates, and the instruction to save space.
A human IT worker would know, hey, maybe I shouldn't permanently delete the folder labeled IRS tax records just to save $20.
The AI lacks that worldly context. It just executes.
Wow.
Therefore, we realize a terrifying truth. Human-level storage security is nowhere near robust enough for AI.
Basic passwords and folder permissions aren't going to cut it.
Not with the sheer speed and potential for literal misunderstanding of an autonomous AI. We can't just plug MCP into a regular hard drive and call it a day.
We have to protect the AI from itself and protect our data from the AI.
We must engineer entirely new safety nets at the architectural level. And this is the true definition of agentic storage.
Wait, so agentic storage isn't just storage agents can write to?
No, as the source strictly specifies, it must be storage designed specifically for autonomous agents.
Built-in safety layers.
Layers that would seem utterly ridiculous, paranoid, and suffocating if applied to human workers, but are absolutely essential for AI.
Okay, this is the payoff.
Yeah.
This is how we build the amnesia cure without burning down corporate headquarters.
Exactly. The source outlines 3 specific pillars of AI-safe agentic storage.
So if standard security doesn't work, how do we stop the AI from deleting the tax records?
The first thing engineers realize is that an AI can never, ever be allowed to truly overwrite or destroy a file.
Oh, really?
Yeah, the first safety layer is called immutable versioning.
Immutable versioning. To grasp how different that is, think about how you and I normally save a file.
Right, you open a Word document, change a paragraph, hit save.
The computer physically overwrites the magnetic data of the old version. The old version is destroyed.
That's standard operating procedure for human computing. But in agentic storage utilizing immutable versioning, that physical overwrite is structurally impossible.
How does it work then?
The architecture relies on an append-only log. Every single write operation creates a brand new, distinct version of the file.
Rather than ever overwriting the existing data.
Exactly.
So if the agent is fixing a bug and updates the script 10 times in a minute, there are now 10 distinct versions saved sequentially on the disk.
Yes. The AI has no physical mechanism to truly delete data. It can only archive it or hide it from the active view.
So if it executes a delete command via MCP,
The storage system intercepts it. It doesn't actually wipe the magnetic tape. It simply flags that specific version as inactive or hidden.
that is a brilliant architectural failsafe.
It completely neutralizes the catastrophic scenario we just talked about.
Because if the AI logically decides to delete the financial database, the system says, sure thing, deleted, and hides the folder.
But when the CFO comes in screaming the next morning that the tax records are gone,
The IT team doesn't panic. They just go into the system and hit undo.
precisely. Immutable versioning provides a complete, foolproof, cryptographic audit trail. You know exactly what the AI did and when.
And you can instantly roll back any destructive action.
It completely removes the teeth from any hallucinated destruction, the ultimate safety net.
Okay, so immutable versioning means I can always undo the damage.
Right.
But honestly, I'd vastly prefer the AI not have access to my critical systems to do damage in the first place. I don't want to have to hit undo on payroll.
And that perfectly logical fear leads directly to the second pillar of agentic storage, sandboxing.
Sandboxing.
Sandboxing addresses a very specific, deeply rooted cybersecurity vulnerability. It basically means the agent is physically forced to operate within a highly constrained environment.
An isolated digital environment.
Yes, it is granted access only to the specific directories and operations it absolutely needs for its job, and it is mathematically walled off from everything else.
The source gives a great example of this. If we hire an AI agent to exclusively monitor application error logs,
Then the sandbox dictates it only has access to the directory labeled logs.
it has absolutely zero path to accessing the system binaries.
The core executable files that make the OS run, yeah. It can't see them, can't read them, and certainly can't write to them.
I do have to ask, though, doesn't standard IT security already do this?
In what way?
Like, as a human employee, I can't casually open the CEO's private folder. My account lacks permissions. Why is sandboxing uniquely critical for AI?
It is highlighted because of a fascinating cybersecurity concept that the source text explicitly names: the confused deputy problem.
The confused deputy. That sounds like a 1950s Western movie.
It really does, but it's a classic flaw in computer security dating back decades.
Let's lean into the Western metaphor.
Imagine a frontier town with a very powerful, heavily armed deputy. The deputy has the authority to do almost anything. Kick down doors, access the jail.
The systemic permissions.
Right. Now imagine a malicious outlaw tricks the deputy. Forges a note saying, the sheriff wants you to burn down the saloon.
The deputy is confused, but believes they are following legitimate orders, so they use their massive permissions to execute a highly destructive act.
The deputy isn't malicious. They are just confused and over-permissioned.
Ah. I see how this maps to our architecture. The AI agent is the powerful deputy.
Exactly. Because we want the AI to be helpful, we might be tempted to give it broad, sweeping permissions to manage the entire server.
We want a super worker, so we give it super permissions.
But what happens if the AI deputy gets tricked? What if a hacker inputs a malicious prompt hidden inside an error log?
A prompt injection.
Yes. Or what if the AI simply hallucinates, gets its logic twisted, and tricks itself into believing it urgently needs to rewrite the core system binaries to optimize performance?
If the AI deputy has broad permissions, it will wander out of its jurisdiction and destroy the town.
And sandboxing physically prevents the deputy from wandering out of town. It creates an impenetrable wall.
It doesn't matter how confused the AI gets or how badly it hallucinates.
The walls cannot be breached. The agent can only burn down its own tiny sandbox, never the saloon.
Beautifully put. Sandboxing limits the blast radius.
Which brings us to the third, and honestly most philosophically fascinating pillar of AI safe storage.
Even within the sandbox, we want the AI to do smart things, not stupid things.
We need a way to verify its logic before it acts. This is called intent validation.
Intent validation. The source refers to this as the chain of thought checkpoint. This is where the storage system actually hits pause and forces the AI to explain itself, right?
Yes. This is a radical departure from how standard storage works.
How so?
Before the layer allows the AI to execute any high-impact operation like archiving data or changing network routing, it physically pauses the execution.
And it requires the agent to explicitly explain why it is taking this action.
It literally demands an essay before it unlocks the door.
That is wild.
Essentially, yes. And this is brilliant engineering because it utilizes the AI's native strengths. We know LLMs can hallucinate, but they are uniquely good at generating logical reasoning and mapping out step-by-step chains of thought.
That's what they were trained to do. So how does this checkpoint actually look in practice? Let's go back to our rogue agent trying to delete the financial database.
Under intent validation, the agent sends the delete file command via MCP.
The storage layer catches it, pauses it.
And sends a JSON RPC message back saying, action blocked, provide reasoning.
The agent then has to explicitly state its logic.
It might reply, I am executing a delete operation on these files because they are large and haven't been accessed in 7 days, which meets optimization criteria.
It has to explicitly show its math.
It does. And only then, the storage layer, which has its own hardened policy rules, evaluates that claim.
The storage layer realizes, wait, policy dictates financial records must be kept for 7 years, not 7 days.
The storage layer recognizes the AI's logic as flawed, rejects the reasoning, and blocks the deletion entirely.
The AI is prevented from making the mistake before it ever happens.
Completely blocked.
I just have to stop and marvel at this for a second. We are quite literally forcing incredibly advanced machines to think out loud.
It's amazing.
We are demanding an artificial intelligence mathematically prove its intentions to another machine before it turns a digital doorknob.
It is the absolute pinnacle of the trust but verify model, adapted for non-human entities.
It's entirely automated machine-to-machine bureaucratic oversight.
And if you combine these three pillars, you get a holistic defense. Immutable versioning ensures we can undo mistakes. Sandboxing ensures the AI can't wander, and intent validation ensures the AI is acting rationally.
We finally have a viable environment. Your autonomous agent gets persistent storage without forgetting everything.
And the CISO finally gets his bulletproof audit trail. He can actually sleep at night.
Knowing the amnesiac superworker isn't going to accidentally delete the tax records over a fleeting hallucination.
He might even learn to appreciate the efficiency of it.
Well, let's just say he'll tolerate it. But honestly, looking back at this incredible technical journey, it is staggering how fast the architecture is evolving.
It really is.
We started with an AI that possessed the memory of a goldfish, trapped inside a volatile context window. We looked at RAG, which was just a read-only Band-Aid.
Leaving the AI unable to write its own history, we explored the logistical nightmare of enterprise storage integration. The sheer impossibility of teaching an AI to speak the different APIs of object, block, and NAS storage.
That friction necessitated the Model Context Protocol, providing a universal translator to let the AI execute tools seamlessly.
But because giving an AI write access is inherently terrifying, we explored how the industry invented a fortified, intent-validating agentic storage system.
Designed specifically for the unique psychology of autonomous workers.
It's a remarkable achievement reshaping enterprises.
And if you are managing IT infrastructure or building software, understanding these hidden mechanics puts you vastly ahead of the curve.
True AI utility isn't just about having a smarter chatbot.
No, it's about building a specialized memory infrastructure for that AI to live in. That's the difference between playing with a toy and deploying a workforce.
I think that is the perfect takeaway to ground all this theory. But as we wrap up our deep dive today, I want to leave you with one final, slightly provocative question.
Ooh, okay.
We spent a lot of time detailing how agentic storage systems now strictly require an AI to provide a logical, mathematically verified chain of thought before it's allowed to execute a command.
The intent validation checkpoint. We're not forcing it to write the essay.
Exactly. It makes me wonder, by building these robust safety nets, are we inadvertently building digital environments that hold artificial intelligence to a vastly higher standard of rigorous accountability and transparent logic than we have ever managed to hold human workers to?
Oh, wow.
And if the AI proves it can operate flawlessly under that immense scrutiny, How long until corporate environments start expecting human employees to explicitly prove their logic before they are allowed to act?
Oh, that is a heavy, fascinating thought to leave on a perfectly optimized, highly scrutinized future for all of us. Thank you so much for joining us on this deep dive into agentic storage and MCP. Keep questioning the systems being built around you, and we will catch you on the next deep dive.